In this video, I'm going to walk you through Lesson 5 of Unit 8.1 from OpenSciEd. Okay, so we're going to start this lesson by looking back a little bit. We're going to navigate in by considering what's doing the pushing and what's getting pushed, and some examples we've already looked at, which is the golf club and the baseball bat. So here's the slide that you will use to facilitate this discussion. And we're going to bring back these icons here showing that this means that it's moving, and this means that it's motionless. And so with a golf club and a golf ball, which one's doing the pushing, which one's getting pushed? And then we think about the car collisions when they're both moving. So this is just to get the conversation started about where the forces are going in these collisions. And then we carry out two pretty simple investigations. The first one is just using fingers, and there's a slide to support you in doing this. And so you have them hold up their fingers and first don't touch them, and we will see that there's no forces. You can't feel any forces on your fingers. And then if I press with this finger on the other one, I notice I can actually feel a force on both fingers. Same thing if I go the other way. So what we're trying to do is develop the idea that even though this one's doing the pushing, I can feel some type of pressure on both fingers. And so it's the beginning of understanding that we've got opposite forces working together here. And so after we do this finger small demonstration, we're going to use some spring scales. And there's a handout that you're going to use. First, students are going to make predictions about which spring scale. So you'll have a spring scale A and a spring scale B, and we use the plungers and we press against each other. So they're going to predict when A is pressing, which one has a bigger force? When B is pressing, which one has a bigger force? When both are pressing, which one has a bigger force? And then we do the same thing with pulls, because a push and a pull are both a type of force. So we make our predictions, then we go through and we use the push-pull springs, and we find out that no matter what we do, the forces are always equal on the spring scales. Whether we use a 5 Newton or a 10 Newton spring scale, whether we push with one or push with both, the forces are always equal. Now, at this point, I do think we have already kind of developed the idea of contact force, but we're going to actually create, it's kind of like a word wall moment, but they call it a contact force interaction poster. I would probably just add this to the word wall. So contact force, you can see there is some definitions. It suggests to do this part in purple first, maybe before you do the spring scale investigation, to talk about what a contact force is when they're touching. And then we add the results of our investigation in the green, which means that the strength of the forces are the same, but in opposite directions. So I would kind of consider this like a word wall moment. And then we're going to plan our next investigation. Here is the handout. You've probably seen this one before. It's where we name the independent, dependent, and controlled variables. And actually, we're going to talk about this setup right here. So you can see there's a metal track. It's taped to the tabletop. And half of the class is going to investigate what happens to the forces when you increase the speed. So we'll do like a regular speed, and then we do a faster speed. And the other half of the class is going to investigate what happens when we increase the mass. And so we use these washers you can see right here, and we do maybe no washers or one washer compared to 5 washers. And so we're going to plan this investigation. Each one is going to write a different investigation question depending on what they're investigating. And they need to have a data table that has less mass and more mass, or less speed and more speed. You can make that data table and add it to your handout if you want, or you can just have them put it in their notebooks. And then we're going to carry out the investigation. And really what we're doing is we're investigating peak force. And so there is a demo video right here. You're going to share this with the class, and we're really introducing how to use that twist tie as a measure for peak force. Now, in the materials, I do talk about the setup of these carts with the push-pull springs. There's a twist tie that wraps around. You can see it right there. When you start, it's pushed all the way up against the cart. So after that cart hits the wall, the plunger presses in and that twist tie moves to the highest amount of force. And so that's what we're considering peak force. And so couple tips I've provided in the materials prep, but you need to explain how to use the twist tie. Otherwise, it's hard to read the peak force. So watch the materials video for that one. After we've done this, we're going to update our progress trackers with what we figured out. And that is that more mass or more speed equals greater forces, but those forces are actually the same in opposite directions. So when I have the two plungers coming together, if it's a greater mass, the peak force is higher, but it's going to be the same on both plungers. So then we're going to engage in a consensus discussion. There is a slide with some prompting questions to help you, but really the biggest thing is you're going to recreate this model. And so in the materials prep, I've provided some directions on how to set this up. You're going to pre-make this side and these two pictures and the titles. You'll pre-make that. And then you're going to add pieces of paper, tape them on for each class, remove them between classes for each section here. So we start by talking about this is the energy perspective. And so we're talking about, this has some kinetic energy, this has no kinetic energy. And we're starting to develop that idea of kinetic energy as energy from moving objects. That's actually going to come back on the summative assessment. So make sure you spend a little time on kinetic energy. And then we're going to be adding from a force perspective, what's happening to the plungers and the peak force. And so I talk about this in the materials prep again, but you will see that these arrows are the most important thing here. That the bigger arrow shows that the peak force is bigger when you increase the mass or the speed compared to these smaller arrows here. So we're using those free body diagrams and those force arrows to represent this in the consensus model. There is an exit ticket, and this is just a slide so they can write it on a piece of paper or an index card and turn it in. And there is actually a home learning reading assignment. It's suggested to go between day 1 and day 2. So if you have that type of pacing, go ahead and do it there. But this is actually bringing in that life science idea about senses and how your brain interprets senses from the receptors or your nerve receptors. And this life science standard is actually sprinkled throughout many different units. In 6.1, we think about how light enters the eye and our light receptors, and that's in the light unit with the double-sided mirror. In 7.1, the bath bomb unit, we're doing smell and odors. In this unit, we do touch. And so each of the units that can be related to this life science idea has it sprinkled in. And here's your moment for touch. Okay, that's it for lesson 5. Take a look at the materials prep because you want to give yourself time to prep for this lesson. All right, let's watch the materials prep video.